Alright guys, welcome to the next video in the data structures lab programs list, and this is program 8. It's about implementing double-ended queue using doubly linked list. So the first things first, so let me tell you what a double-ended queue is. A double-ended queue is a queue in which the operations deletion and insertion is done at both the ends. So coming back to what linked lists are, so basically a linked list is a group or a bunch of nodes linked together to form a list. So that's what a linked list is, and that's what you have to remember as a beginner programmer, what a linked list is. And each node in the linked list consists of two fields. One is the information field that holds or contains the data stored in it. That may be integer, float, or character values. And one is the link field. So that basically points or has a reference for the next node in the list. So collection of such nodes linked together forms a linked list. So a doubly linked list is a linked list in which each node has two fields. Two link fields. A single linked list has a single link field. A doubly linked list has double link fields. So basically, when we are talking about doubly linked list, we say one node contains one information field and one left link and one right link. So left link is a pointer that points to the previous node in the list, and right link is a pointer that points to the next node in the list. So that's what basically doubly linked list is. And another thing you have to remember about doubly linked list is that the first node in the list contains null for its left link, and the right link of the last node in the list is null. So proceeding to the program, this program is about implementing a double-ended queue using doubly linked lists. So whenever we talk about linked lists, we talk about nodes, and how we implement a node, we do it using structures. So since we have data of more than one data type, we implement the node using structures. We say struct node, and we have one integer data type, one integer variable here called info, and we have two pointers, that is left and right. That is, the pointers are of the type struct node as well, just because they'll hold the address, or they'll point to the next or the previous node, and those nodes are of the type struct node as well. So that is the reason why we have pointers, the left and the right pointers of the struct node type itself. And coming to this line, we say type def struct node capital NODE node. And this just means that this just tells the compiler that whenever I say the capital node in my program, just replace that with struct node, the two words struct node. Whenever I say the capital node, it replaces every occurrence of that with the two words struct node. So basically just helps us type just one word instead of two. Doesn't do much. So let's talk about how we're going to create nodes for our queue. We say the single node contained one information field and two link fields, and whenever we're going to create a node, we say we write a function for creating node for our double-ended queue, and it is like this. We say get node, the function name, and the return type of the function will be node pointer. So whenever we say the capital NOD in anywhere in our program, it means that struct node. So we say node pointer, so that's what it's going to return. And we say the function name get node, and it takes one parameter that is of the type node pointer as well. And the first line in the function is node pointer new node. We create, or we declare a new structure variable, and structure pointer variable perhaps. So then we say new node is equal to node pointer malloc size of node. So what we do is, after we declare a new structure pointer variable, we allocate the size, we allocate memory for that variable. So we say new node is equal to node pointer. We typecast the void pointer returned by the malloc function, and then we say size of node inside malloc. So malloc is takes one parameter, that is size. So size of node is what we want to allocate to the newly created node pointer. And we next is the new nodes right is equal to new nodes left is equal to null. So we nullify the links. Of course, we created the new structure pointer variable. It has three fields, one info field and one left link and one right link. So we nullify the links. We say new nodes right is equal to new nodes left is equal to null, so that the left and the right links doesn't point to any node or any location in the memory yet. And then we prompt the user, we say printf enter the info. Then we obtain the input for the info field by scanf, and then we have flush all function over here. I don't know why they have given that. Basically what flush all does is it clears or flushes out the input and the output buffers, and sometimes works without that line as well. So then we assign the new node that we just created to a variable head. Remember, head was the parameter that we just obtained from the argument list of the function, and we say head equals new node. We assign the newly created node to head. We return head. So this is what we do when we basically create a node. So this function does all the things for whatever is required to create a node, and then returns that newly created node. So when do we call get node is what really matters. So we write another function, another routine, get node, for calling get node. We write a function called create, and the return type of the function will be node pointer as well, and it takes one argument, that is head, which is of the type node pointer as well. And we create two node pointer variables this time. We declare two pointer variables of the type node, and what we're going to receive as the argument is the node pointer head, and that will be assigned to P. P is a node pointer that we just created, and we check for the condition that whatever head we received, the node we received, we check for the nullity of the node, and if head equals null, we say new node is equal to get node of head, head equals new node. And the first line in this, so if head double equals null, this basically checks for the condition if this is going to be the first node of the linked list, then we do new node is equal to get node of head. Remember get node that we just discussed earlier. If you want, just go back and rewind and check that thing out again. And then we say head equals new node. Here head is the parameter that we received, so we check for the condition if head equals null. So that basically checks if this is the first node in the whole list. And then we say new node equals get node of head. Head, we assign the new node to the head again. And if it's not the first node in the whole list, we go to this part, else. If head equals null, execute whatever is here. Else, we say new node equals get node of head. So anyhow, even if it's the first node or not the first node, we create a node by calling the get node function. We pass the parameter head, and while this line here is very important, while P's right not equals null. Remember P was assigned the value of head, so while P's right not equals null, P equals P's right. So what basically this line does is, if head is not equal to null, get into the else part, get a node into the new node, and check if right link of P is null. Traverse till the end of the node list. So that's what this lines is going to do. So P is right not equals to null. What are we basically checking here is P is a node pointer, and if the right link field of the P, if it's null, that's what we are checking. And if it's not null, we say P equals right. I'll get back to you later regarding P equals P's right. So that just helps us to move one node forward. And after the loop, we say P's right is equal to new node. So when this loop finishes running, we will be at the last node of the list. So at the last node, we insert a new node, or we link the last node's right link field to the new node. So that's how we basically create. Suppose if there is no linked, if there is no node in the linked list, we check for this condition, and this condition will be true, and the first node will be created. If it's not the first node, then the new nodes are appended or just joined to the end of the list. So that's how basically this create function works. We return the head pointer back to the called function. So then we see how we can display and count the nodes. So we write a function called display, and the return type of the function is node pointer as well. I don't know for what reason they have made it like this. It was there in the syllabus that way, so I'm just teaching the way it is. And takes one parameter, node pointer head. First line is we create a new structure pointer variable node star p, and again we check if head is equal to null. That's again checking if the linked list is empty. If there are no nodes in the linked list, head will always be null, and I'll show you that we assign or initialize head to null in the main function before whenever we create it for the first time in the program. So if head equals null, we output no employee data and we exit from the program. If it's not null, if there are nodes in the linked list, we say p equals head. We just assign the head pointer to another pointer p, and we just display the data whatever's there till p is not null. So basically what's happening here is if there are 5 nodes in the linked list, we'll display, though this while loop is going to display all the information from the 5 nodes, and then it will terminate. And then what this condition will basically check is if the right link of the last node will be null. So when it reaches the last node, the right link of the last node will obviously be null, and then hence the loop terminates. And at last we say printf the number of nodes in the list is count nodes. We have another function here, and I'll tell you later how that function works, and we return head. So this is basically how we display the whole list. So it doesn't have to be much complex, but this is how it's done in our syllabus. And we just check for one condition, if there are no nodes in the linked list and if there are any. So based on the condition, we proceed. So next is to count the number of nodes present in the list, or our queue. Now we write a function, we name it count nodes. The return type of the function is integer. Basically, it will return the count of the nodes, and takes one parameter, node pointer head again. So every function, every routine in this program takes the same parameter. So I've included why it's done so in later part of this video. And the first line we say we create a structure pointer variable node star p, and we initialize let's create a new variable, integer variable count, and we initialize it to 0. We copy the contents of head to p. Basically what we're doing is we just copy the reference what's present in head to p, and we use p to traverse or do whatever we want with the linked list. So we say while p's right's not equals null, we go right. So p equals p's right. That's what it basically does. It takes us one step right, and yeah, while p's right not equals null, p equals p's right, count plus plus. So whenever we encounter a node, we say count plus plus, and we traverse till the end of the linked list, till the last node, and then the loop terminates. Then it returns count. That will have the number of nodes present in the linked list. So next, these are the points to remember. I've included right here, very important, and will help you write this program for yourself very easily without having to by heart or keep things in mind to write the program in an examination or whatever. So the first point is we cannot refer to any node present at a random position in the linked list. So that's why we traverse, right? So very important point, we cannot refer to any node present at a random position in the linked list. Suppose the linked list contains 6 nodes. You cannot just point to a third or the fourth node by random. You cannot, there is no way of doing it. And The next point is for any operation such as insertion or deletion either at front or the rear end, traversal is the first step. So whatever you do to the linked list, whatever you implement, a queue, a stack, or whatever, there are operations we insert and delete from rear and the front end, right? So you do that by either moving from the first to the last node and then operating there, or just last to the first, or just being it first and operating things there. So next is the operating at the rear end. To insert at the rear end, we create the new node. Just observe this or just listen to me carefully. To insert at the rear end, we create the new node, traverse from first to the last node, then link the newly created node to the last node, which is apparently insertion at the rear. So these are just simple basic techniques that you have to remember in order to write the code by your own for yourself. To insert at the rear end, we create the new node, traverse the list from first to the last node, then link the newly created node to the last node, which is apparently the insertion procedure. So similarly, to delete from the rear end, we traverse till the last node and then delete the node, making the previous node the last node after deletion. Just as and when you read this on the screen, just imagine or picturize it in your mind that to delete from the rear end, from the last, basically you want to delete the last node, right? You traverse till the last node because there is no way of getting directly to the last node. You traverse it till there and then delete the node, so making the previous node the last node after deletion. So operating at the front end, to insert at the front end, we create the new node, link the newly created node to the first node of the list and make that new node as the first node, making it the starting node of the linked list. So there's a slight difference between inserting at the rear end and inserting at the front end. To insert at the rear end, you go to the last and then insert the new node. So here, first you create the new node and first you link the newly created node to the first node of the list and then make the newly created node the first node. Just picturize things in your mind and everything will make sense to you. And that's how insertion at the front end of the queue or linked list perhaps is done. So to delete at the front end, it's the first node that we have to delete, right? So we make the second node as the first node of the list and then delete or do whatever you want with the previous first node. That is there. So these are the basic points to remember that that'll really come in handy whenever we think of writing logic or writing the piece of code that you want to insert, delete, or do whatever in the linked list. And here are a few tips and tricks for you to implement doubly linked lists. So the first point is use a temporary pointer to traverse the list so that you always have the address of the first node in a fixed variable for later use or whatever. So the address of the first node in the list is just have the address of the first node in a fixed variable. For example, we use head in this program, right? And we use current pointer or p or whatever it is to temporary pointer variable to take the address of the first node and then traverse throughout the list, so that you can always have the reference to the first node aside. So the next point is, suppose p is the node pointer, traversal to the right is by p equals p's right, traversal to the left is by p equals p's left, and use any of the above statements in a loop to traverse from one end to the other, checking for the nullity of the appropriate link. So for example, while p's right not equals to null, p equals p's right. So this statement will help you move from left to right. So, or just traverse from first to the last node. So traversal to the left, just observe the first two lines of the second section here. Traversal to the right is by p equals p's right. Traversal to the left is by p equals p's left. So these are the few basic tips and tricks that every data structure or algorithm is to remember, or just to make things easier, you know. These are all the basic things, basic logics that you can remember to write your code faster without much thinking. And the next point is always hold the address of the first node in a fixed variable and make sure to update it after each operation, which apparently maintains the whole list every time it's operated on. So in this program, we have an example, head equals insert head. So whenever you delete or insert at any end of a linked list, make sure that the main variable, pointer variable that holds the first that holds the address of the first node in the linked list, always keep it updated. So that's what it means. So whenever you insert, make sure that you update the main list. Of course, you traverse the list from first to last, then delete it or whatever it is, then assign the the address of the first node back to the fixed variable again, so that every time you do an operation, the whole list, the main list, is updated. So that is all the basics you need to implement doubly linked lists, and this is not one of the difficult programs I've seen so far. And let's take a look at the code and the output. Yeah, and here is the code for the program we just discussed. Now, I know it's been really boring watching this video for 20 minutes for now, and I'll just finish this real quick by just explaining the main function. Here's the main function for the program. We have the first and the foremost node pointer, that is head right here. We initialize or assign the value null to it, the very first step. So we have this infinite loop here. This is the infinite loop. We give the choices to the user: create, display, insert, delete, and finally exit. We input the choice, we pass the choice in a switch case, and the first case will be to create the nodes. So we prompt the user for a number of employees. We obtain the number of employees in a variable n, and we run the for loop as many number of times as the number of employees. So we say head equals create head. We discussed the create function earlier, so you know what it would do. It creates as many nodes as the user wants. So the second function, the second case, is to display the nodes in the linked list after creating. So the third case is to insert, and the fourth case is to delete from the any of the ends. So insert and delete, we have internal choices in these functions, so whether to insert at the rear end or the front end, or delete at the rear end or the front end. So just go through the source code, and feel free to comment if you have any doubts regarding any line of the code, and I'll be happy to answer if I know. So that's basically this. All this stuff contains the basic lines that we just discussed in the points to remember and the tips and tricks section. We have p's left, p's right equals null, all the basic stuff. You really understand the code once you understand the concepts and the basic principles and the standards, how things are done in linked lists. So that's it for today, guys. Thanks again for watching. See you again in the next video. Till then, take care. Bye-bye. Please don't forget to subscribe.